Hey guys, right now you should be logging in to YouTube and finding this live stream so that we can have our video lesson for church chemistry. I'm going to wait until I see everybody typing their name into the chat. I know that Jordan might be a little behind on that, so I will give you guys a couple minutes. Don't mind the awkward silence as I sit here and just look at the screen, because I don't want to start until I know everybody is watching. So give me a couple minutes and we'll let everybody try to log in before 2. Alright, Emily, just a reminder, you are going to need your book and paper and pencil, and I am going to try to have some practice problems from a worksheet that I sent you guys on Edmodo. So if you have a way to look at that as well, like if you split your screen, that might be helpful for you. So go ahead and split your screen, Emily, and look on Edmodo and try to find the assignment that I sent you. You should be able to click on it and you'll see a worksheet where you are having mixed naming worksheet review over ionic, covalent, both ionic and covalent bonding, and as well as acids. So make sure that you are able to see that. There's like 100 questions, and so we're going to go over a couple of them in class so you don't have to do all 100 on your own. That way, you've got a little bit of help. Alright, I have one Emily. I should be getting my other Emily soon. So, Emily, if you are here, please let us know by typing your name in because I don't see you here. So let us know as soon as you join because we would like to start before 2, and it's 1:51. I know that Jordan should be joining us soon as well. Again, if you are here, Emily and Jordan, please type your name in the chat so that I know that you are officially able to see this because we are waiting on you. So as soon as you find this video, please just type in your name and we will get started. Alright, good. So 2 out of 3. And we've got about 3 minutes before we're officially starting, but I am going to remind you guys, please have your book and paper and a pencil, and also you may need to split your screen on your computer so that you can go back and forth between the live stream and this worksheet, because we are going to do some practice problems from that worksheet. Emily, I did put that in Edmodo. It is an assignment that is going to be due, and I don't think that I'm going to be able to check your homework over this because I can't see anything from you, Emily. So I'm going to have to check that homework on Thursday when we meet in person. But thank you for suggesting it. So I am going to say that this assignment, this worksheet, the naming ionic, covalent, and acid, that mixed review worksheet is going to be due. There are 100 questions, and so we are going to practice some of those so you don't have to do all 100 for homework over the next 2 days. So we are going to be working from problems from your book and then from this worksheet to get you some practice in both areas. If you are unable to find the worksheet and have the live stream up at the same time, that's fine. What I'll do is I will say the examples out loud so you can always write them down in a notebook or something, and that would be just fine as well. Alright, 2 more minutes. I don't like sitting here doing nothing. It's kind of nerve-wracking, so I will just have to be patient and wait 2 more minutes, and then we will officially start right at 2 o'clock. And yeah, we'll get started. Hopefully Jordan will find this video and be able to log in and join us on time. We gave him a little bit of a buffer, so we'll see if he joins this class. My other disclaimer before I start, I am kind of sick, guys, so please bear with me. I don't sound like myself, and I might have to blow my nose once or twice. I do also have some sweet tea here to drink, so that if my throat gets too sore, I will be able to take a drink and hopefully help that. So please just bear with me. I'm sorry that I sound a little funny. Alright, it is 2 o'clock, so I do hope that Jordan is able to find this video and join up. And Jordan, as soon as you do find it, please just type your name in and we will get started. I am going to start by saying you should have watched all of your 8.1 and 8.2 videos. So this video right now, the live stream, is not so that I can reteach you the fundamentals that you already learned about how to name ionic and not ionic, we learned that in the last chapter, but it's not to reteach you how to name things like acids or covalent bonds. It's actually to practice this. So what I'm going to be doing a lot of is asking you to name something, and then I'm going to have you type in your response, what you answer. So that way I can help you practice this correctly. So we're going to be doing a lot of practice today. And then we're going to do the reverse as well, where I'm going to give you a name and you will write the formula. Now, to make sure that we're all on the same page, when you write a formula in this, you can just put a subscript, just use a large number. So if you had to write H2O for water, you just write a capital H, and then a big 2, and then a capital O. And that's how you would type that in, and I would understand that you meant H2O. Alright, let's go ahead and get started now that formalities are done. Yay! So that's perfect. We're all on the same page now. What I'd like to start with is reminding you guys that ionic names, when we were naming things like if we had lithium and chlorine together, you would say the cation first. So you would just say lithium, and then you would say the anion. So you would say chlorine, but we had a special ending that we added to the end of the word chlorine, and we would trade it out so you have this suffix. So I would like you guys to type what that suffix was that we would add to the end of the root of the second element, or the anion. So type that in for me. What is that suffix? Well, I'm waiting. Close, but not quite. That's it, Emily. So it's not I-T-E. It's not ite. It's ide. We would use the suffix I-D-E. And so we would say lithium chloride. The important part about this is when we move in to our covalent bonding, we are still going to follow some of the same patterns. There's just a little bit of a difference with this, but it's going to have most of the same patterns. The first thing is we still say the first element first. For instance, if we had carbon and chlorine together, like CCl4, we would say carbon first. And then we would say chlorine second. But just like with ionic substances, we use that special ending IDE. So we would add "ide" to the end of the chlorine. So we'd say chloride. The only other thing that's different with covalent naming is going to be that we're going to use prefixes to tell us exactly how many of each thing we have. So if we have one carbon mixed with 4 chlorines, we would actually say carbon tetrachloride. That would tell us that we have 4 chlorines. And so that's how we work with covalent names. Now, on page 248, so everyone can turn to page 248, there's a table 8.3. And this is going to tell you exactly which prefix to use. Now, I would suggest that while you practice, have this table open and refer back to it. It's okay to look at the table when you're just starting out. Now, eventually, you need to have these memorized, and you need to be able to just know that 8 should be oct, and 1 should be mono. Those should be things that you eventually just start to get good at, but as you're starting the practice, refer to this table quite often. Now, there's a few things that are a little bit different with this, like the first word, if you have one of them, you don't have to say mono. But if you have 2 or 3, you do have to include those prefixes. It's only mono that we don't include. The reason is because so many molecules out there start with one element first. And so it would be very redundant to start with mono, 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 mono. It's just like when you're alphabetizing a book or a movie. If the book or movie starts with the word the, you don't actually start by alphabetizing it with the word the. You actually start with the second word, because otherwise we would have a bunch of books, and then we'd have this huge section in the library where you'd have the and then the name of the book. So we don't actually include the prefix mono on the first word if there's only one of them, and that's why. So that's an exception. Another exception is that when you have 2 vowels repeating, like, so if you have monoxide, M-O-N-O-O-X-I-D-E, monoxide, you don't want to keep both of those O's, because otherwise you'd say monoxide, and it just sounds weird. So we're going to drop the vowel if there's a double vowel. Really, you guys just need to practice this. So I'm going to start having you guys on page 249. Notice how you have CO2. I'd like you to type in the name for that, for number 14. So type the name for what you would name this as. And I want the whole thing, so not just the second part of it. I want you to type in the whole thing for CO2. I'm going to be right back. My computer just got unplugged, and I do need the battery. Otherwise, I'm afraid we might lose this live feed because my computer might turn off. I'm back. Alright, so we have a little bit of disagreement here. I want to point out, how many oxygens do you have? And the fact is you have 2 of them. So what's the prefix for having 2 oxygens? So you're going to have to look at your prefixes in covalent compounds, find 2, and see what that prefix is. So I'm going to say, Emily Mungold, you are the winner. You got it right. It's not carbon monoxide, because that would mean 1 oxygen. This is supposed to be carbon dioxide. And you've heard that name before. We breathe it out, and so it's not a new name, but that's where it comes from. It's telling you very specifically in the name. You can picture it. You have 1 carbon, 2 oxygens. And so I love naming covalent compounds because it's just so natural and so easy, and it tells you exactly how many of each element you have. So let's go ahead and practice some more. I want you to practice number 15, SO2, and number 16, NF3. So type both of those in. They're actually numbers 15 and 16, SO2 and NF3. So that's where you got the number 3, but it's number 15 and number 16. Good, you guys are correct on the first one, sulfur dioxide, because there's 2 of the oxygens. Notice how in this one and in the carbon monoxide we didn't have to say monocarbon monoxide or monosulfur dioxide. We didn't have to do that. So good job on that. And what about the next one, NF3? Oh, Emily, we're not on the worksheet yet. We're in the book. Yeah, we're going to do the worksheet after we work in the book first. Good. Alright, Jordan, you are correct. Nitrogen trifluoride. Emily, glad that you're on the same page now. And Emily, what's the second half of that instead of just nitrogen? Got it. Okay. The reason that we have trifluoride is because how many of the fluorines did we actually have? So you have to look and you see, okay, well, we have 3 of them. So all you have to do is go to the prefixes. Remember how I told you to use that table a lot while you're practicing? So go to the prefixes and see which prefix is used for the number 3. And so you look at it and you go, number 3 is tri, just like a tricycle. So you would say trifluoride. Just like how you said dioxide when you had 2 oxygens, you just say, oh, got it. Well, the tri is right there, and then I guess you'd have to, if you want, the back of your book has a periodic table, and so you can look at how to spell fluorine. And don't worry, I won't, in this feed, I won't be counting off for spelling, so that's okay. Alright, so now that you guys have that idea, what I'm going to do is have you guys look at the practice problem, or the challenge problem, which is asking you to write the formula. So notice they're switching it around on you. They're going to give you the name, and you have to write the formula. So notice that you have, write the formula for diarsenic trioxide. And Jordan, I'm going to say you are correct, except look at your ending. You have carbon tetrachlorate, but is this chlorate? Because we have a special suffix that we're always supposed to use for these. So what should that suffix be on carbon tetrachlor what? I'm on page 249, and you guys are supposed to be practicing number 18. Jordan had done number 17 as extra, and so I was just responding to him. Alright, so let me type this in for you, Jordan. Ide. So it should be tetrachloride, like that. So that's how you actually write tetrachloride, because chlorate and chlorite are actually polys. And if you remember, the polyatomic ions are going to be like carbon with oxygen, or in this case you said chlor, so that's chlorine with oxygen, and so you would use that when you have a poly. But in this case, we don't have a poly, we just have the element chlorine. And so because we only have the element chlorine, well, we have carbon and chlorine. So that's why you would say carbon tetrachloride, because you would reserve that ite and ate ending for if you had ClO3 or something like that. Alright, so now what I actually asked everybody to do was to answer number 18, which is the challenge problem, which is writing me a formula from this name, diarsenic trioxide. And if it's tripping you up to find arsenic, arsenic's symbol is AS, so capital A, lowercase s. And so I want you to write the chemical formula for diarsenic trioxide. Good. And don't put a space between them. Just squish those right up next to each other, Jordan, so it's AS2O3. Good. And so there's no space between them. Yes. Emily, the only thing I'm going to say is you do actually have to lowercase the s, because remember, in the periodic table, the first letter in an element is capitalized. The second and third letter, if they have 2 and 3 letters, are always lowercase, and that helps us know whether we have AS, which is arsenic, or whether we have A and then element S, which is sulfur. So make sure you use the lowercase when you're doing the second letter there. Alright, so we're going to go on in our book to practice naming acids. And I know naming acids tends to be scary for students, but I really would like to encourage you guys that it's not that hard. You just have to be very, very systematic. So I know some of you guys might not like that very much, but we have to be systematic when we're going through this. And I always think through the process the same way every single time. And I did put that in our, the video that we had where we were talking about how to name acids, but I'd like to remind you, and I want you to write it down as a reminder. There are 2 types of acids out there. There's going to be binary, and there's going to be oxyacids. Now, binary acids have 2 elements, and that's it. They're always going to have hydrogen and then something else mixed with a hydrogen. An oxyacid is going to use an oxyanion, which remember is one of those polyatomic ions that we memorized, which is why we had to memorize them. So you're going to have hydrogen and a poly. I want to remind you guys, let's just say that we're starting with the understanding of what an acid is. An acid is defined as a hydrogen donor. Let's just say I defined myself as, yes, Emily, you were, so I think that's probably why there might be a little confusion. I had told you guys to, by Tuesday, watch all of 8.1 and 8.2 videos. So that is needing to be taken care of before Thursday, alright? Alright, so if I say that I'm a $5 donor, okay, I'm going to give $5 to somebody. I cannot do that unless I have $5, right? I have to have $5 in order to donate $5 to somebody. Essentially, that's what an acid is. An acid is a hydrogen donor. It has to have hydrogen because if it doesn't have hydrogen, it can't give away a hydrogen. And so the fact that it's defined as a hydrogen donor, that's why you know acids always start with hydrogen. It's the first element you're going to see. Now I want you guys to think separate in your mind. When you are naming covalent molecules, you use the prefixes like mono, di, tri, tetra, and so on. When you are naming acids, you do not use those prefixes. It's only for covalent molecules. So when you're naming acids, your brain has to go to a completely different place. When you are naming acids, you should go binary or oxy. Alright, is it a binary acid or is it an oxy acid? When you think binary, it's going to be hydrogen and something else. It could be hydrogen and chlorine or hydrogen and sulfur. Doesn't matter. If it were to be an oxy acid, it would be hydrogen and then an element and an oxygen, right? Because we have a poly in this case. They're always oxy anions, so they always have oxygen in them. So the difference matters because you're going to use the rules differently. And I want you to write it down. The first thing you do with a binary acid is you have the prefix hydro. You put the root of the element. The hydro represents the hydrogen. You put the root of the second element, and then you put ic at the end. Hydro, root, ic, and then you just say acid. I'm going to type that in for you guys so you can see this. That is the way that it's going to look if you have a binary acid every time. So the hydro in your mind, when you see the word hydro, it should indicate two elements. That's it, hydrogen and something else. So if I have hydrogen and chlorine, I would say hydrochloric acid, and that's all. If I have a poly though, let's say I have H2SO4, and I have H2SO3. Those two are not binary because they have hydrogen, sulfur, and oxygen. And so those we would think not binary acids, we're going to think oxy acids. And the way that you do an oxy acid is you never use the prefix hydro. Oxy acids never have the prefix hydro. Instead, you just name the oxy anion, whatever its name is. So SO4 is sulfate, and SO3 is sulfite. So you would say sulfate. But you change the root. And I'm going to type this in as well. The root 8 becomes ic. Us becomes it becomes ic, and ite becomes us. Alright, I do have a clever way to remember this, and I have it for 8. If you ate too much at dinner, you might become sick. So remember 8, any oxyanion that ends in 8, you change that 8 into an ic. So 8 becomes ic, ite becomes us. And then you just say acid, and you've named it. So you don't have hydro, you just go, if you had sulfate, SO4, you'd say sulfuric acid. If you had sulfite, SO3, you would say sulfurous acid. And that's all you have to do with your acids. Alright guys, I can't see your faces, so I can't tell if you guys are on the same page, or yes, if you ate too much you will get sick. That's correct. So I'm going to give you some practice and see if you're on the same page with me and see if that made sense. So we're going to start on page 251 with number 19. Notice how it's HI. So what I want you to do is name that acid for me. And the first thing you should do when you think acids Is it binary or is it an oxyacid? So go ahead and start by thinking that and then writing down your name for that HI. Excuse me. Close, Emily. The only thing is, which root are you supposed to use? This is I, which is not chlorine. So which element is element I? But you did have hydro and ic, correct, by the way. So just change that root. Good and good. Jordan, you're also going to drop that N. We'll have to talk about weird spellings when we meet on Thursday. But you don't actually keep the N. It's not part of the root. So when you would write this, you would just write. Good, Emily, only you have to have the O because you just have hydroiotic. So let me type it in for you guys. This is the correct spelling. Hydroiotic acid. I will help you guys on the spelling, but let me see, Emily. Hydro. The only thing is you would need to drop that N. That's all. I think mainly with some of the spellings like sulfur, they keep the R, because it sounds weird if you say sulfic, but with iotic, it sounds weird if you keep the N, because then it's ionic, and that doesn't sound right. So that's why they dropped that N, and a lot of times it just has to do with, it just sounds better, I think. So we'll go over again. The more you do these, you just pick up on the weird nuances with which letter is dropped and which one is kept. But mainly, the thing I'm looking for now, since this is just your first time practicing, is that you are getting the correct root of the element and that you have hydro and ic on there, because that's the really important part. We can work on the exact spelling later. Well, I don't think it's super confusing. I think it's just new. That's all, Emily. So we're going to keep working on it. Alright, so now what I want you guys to do is look at number 20. Before you try to name this, what I want you to do is notice HClO3. ClO3 is an oxyanion. That's one of your polys. So I want you, before you name this acid, to name your poly. And when you work on these, that's what you should do. You should go, oh, that's a poly, name the poly, and then work from there to name your acid. So what I want you guys to do right now is type the name of that poly. So type in the name of ClO3. Okay, I'm going to go ahead and go on. I know Jordan hasn't answered yet, but you guys both have said chlorate, and you are correct. So now that you know that ClO3 is chlorate, all you have to do is figure out if that becomes ic or us. And so we go, then 8 becomes, and yes. 8 becomes ick, so you guys got that right. But what did I say about never using which prefix with the oxys? Never use hydro. You just say the poly, and you just change that ending. So we're not going to say hydrochloric acid. Instead, we would say what? Good. So I'm seeing the consensus. It's just chloric acid, and that's correct. Now, I'm going to try to explain to you guys why, because I'm going to type something in here that's not actually practicing in your book. But ready? What would this name be? Just HCl would be named what? Because that's a binary acid, we would have to have what prefix? We'd have to say, and I'm waiting. Good. So now string that together for me. Since you need to have hydro because it's binary, you would actually call this acid hydrochloric acid. Do you know why I pointed this out? Because when you have HClO3, that's why you can't say hydrochloric acid for the poly. Because if you did, it'd be really confusing. You wouldn't know whether you had HCl or HClO3. And so remember, that's why we never use hydro when we're dealing with an oxy acid. We only use hydro for binary acids, so that you know the difference between when you have chloric acid, which is HClO3, or when you have hydrochloric acid, which is HCl. That's the difference. So that's why you use hydro and why you don't use hydro. It's because the word hydro should instantly, when you see that prefix, you should go, it's binary. There's only 2 elements involved. If you don't have hydro, you should go, all right, it's going to be an oxy acid, and so I need to know what poly I have. All right, so now let's go ahead and practice the next one, which actually ties in nicely with this because it's HClO2. So please name HClO2 for me. Excuse me. Alright, so Emily, focus on the poly. ClO3 is chlorate. ClO2 is chlorite. So what happens to that ite? Ite becomes what ending? Not ick. Remember, ate becomes ick, because if you ate too much, you'll get sick. So what is ite going to become? And yes, Emily, you are correct. Yes. Jordan, an oxyanion is a specific type of polyatomic ion. It's referring to the polyatomic ions that have oxygen in them. So it's not actually like CN, which was cyanide. It would have to be all the ones that have oxygen in them, like SO4, SO3, ClO2. Those are the ones we're talking about when we say oxyanion, or they're the polys with oxygen in them. Good job, Jordan. You got that one correct. Chlorous acid. Alright, so I think that most of you got that it was chlorous acid. I'm sorry. I should just call you guys thing 1 and thing 2 because there's 2 Emilys in this class, and it's really hard to distinguish between the 2 of you guys, especially when we're on a live feed. So there we go. And yes, Emily M, you are correct. Alright, so here's what I'd like you to do. Please practice number 22, which is H2SO4, and number 23, which is H2S. And so again, they're trying to drive home the difference between your binary acids and your oxy acids. So try to make sure you catch the difference between those two. Alright, so you'll be thing 2 or Emily 2, I guess. I like calling you guys thing 1 and thing 2. I think that'd be fun. Yeah, we're gonna have to make them shirts or something. Alright guys, I hope you're as well as joking about the thing 1, thing 2. I hope you're answering number 22 and number 23. So I'm waiting for that. Good. I'm sorry. It's terrible blowing your nose in public. It's even worse blowing it on a video stream. Because now it's on video forever. Emily and, thing 1 and Jordan, you guys are correct. Sulfuric acid is the first one. And then, how is it different from just H2S? So I want you guys to really quickly type that one in. Good, that is correct. So you have to have that hydrosulfuric acid when it's H2S to help you remember that it's binary. Alright guys, acids aren't that hard, are they? I mean, now that we're getting the practice and working with them, you just have to think, is it binary or is it an oxy? If it's binary, it's got hydro, root, ic, acid. And if it's not, then it's going to be either 8 turning to ite. I said that wrong. 8 turning to ic, or ite turning to us. And then you just say acid, and that's it. So let's go ahead and do some more review. What I'd like you to do now is actually try to work on the mixed review. So the mixed review is practice problems 25 through 29. Oh, it's not mixed review. I'm sorry. This is where they reverse it on you guys. And they're going to give you in 25 through 29, they're going to actually give you the name, and you have to type the formula. So do me this favor when you're typing in your answers. Put the number, like if you're answering 25, type in 25 and then your answer, so that I can keep track of which one to check. So go ahead and try to answer those as fast as you can, and then we're going to work on, yes, still in the book, and then once we're done with these problems, we're going to go on to the worksheet. I have a question for you guys. My book has 2 typos right off the back. I don't know if yours does. 25 in mine says silver chloride. Does yours still say silver chloride? Because if it does, it should actually say silver monochloride. And then number 26 says dihydrogen oxide, but it should say dihydrogen monoxide. So if your book doesn't have that, please correct it. And that would help you. With number 25, there's no oxygen, it's just silver and chlorine. The "ide" helps us realize that it's, the suffix added to the chlorine, the root. So it would just be AgCl, not AgClO or anything like that. And then let's see. Alright, so Emily Mongold thing 1, you got it correct. But for the other ones, just remember it's supposed to be silver monochloride, and so that would be just AgCl. Then for number 26, good. That is the technical way to write down the name for water, dihydrogen monoxide. It's just H2O, so that's correct. Well done. And then let's see, chlorine trifluoride. Jordan, you're a little off, but let's see if you can try to figure it out. For number 27, it just says chlorine trifluoride. So if it says chlorine trifluoride, do you hear oxygen anywhere in that name? And don't add oxygen. These aren't oxyanions or polys or anything like that. These are just normal covalent bonds. Good on the H2O. Those are both correct. Good on number 27, ladies. So you got that correct. It's ClF3. And again, Jordan, I was pointing out to you that there's no oxygen in that one. You would hear it in the name if it was in there. If they have a poly, they will name it as the poly. So if we had had this as chlorate or chlorite, and in that case, the way you wrote it, Jordan, it would be hypochlorite and then trifluoride. So you would actually have that in the name if it's going to be an oxy or oxyanion or a polyatomic ion, then it would be in the name. And so since it's not, you know that it's just the single element chlorine. And then for the last one, 28, well, that's not the last one, second to last one, diphosphorus trioxide. Let's see what you guys have. Diphosphorus trioxide, I see Jordan, good, that's correct. P2O3. And then Jordan, you have the last one, disulfur decafluoride. You are correct as well. Good job. Okay, so Emily Mongold, thing 1, you missed the, in 28, notice that it says diphosphorus, not just phosphorus. So what needs to be there if it's diphosphorus? Emily, thing 2, Emily, you are correct. It's S2F10, that's correct. Yes, good. Alright, so I think that we're all done with 25 through 29, so that's it for the practice problems of your book. And so what I want you guys to do is to find your worksheet that I've assigned to you for homework. You're actually going to have this be due on Thursday. I know there's a lot of practice problems. There's 100 of them. Let me make your life a little easier. I want you to do 25 of each. Alright, so you're going to answer for the first half, naming compounds, do the first 25. Notice there's a little weirdness with the way that they numbered them. They go down to 13, and then on the left column it says 27, but number 14 is already on the other column. So be careful. Actually do numbers 1 through 25. Then on the bottom half, you notice that you have writing formulas from the names, and so I want you to do numbers 51 through 75. Alright, so I'm going to only ask you to do Emily Carr, there shouldn't be 150, there should only be 100. And Jordan, the worksheet is actually in Edmodo, so what you'll have to do is open another window on your computer or use your iPad, because I know you have a laptop and an iPad. So maybe open your iPad and go into Edmodo. And in Edmodo, I sent you an assignment. And the assignment actually is this worksheet. So you just click on it and it'll open up this worksheet. And so what I would like you guys to do is actually practice those. So we're going to do, I'm going to say, we have enough time to do about 5 of each of these sections. And so we will do the first 5 together for each section, and then you guys can finish the next 20 afterward. So that way you have some good practice, but and you watch and read 8.3, yes. So we are going to, on Thursday, we'll go over the answers for these, and then what we will also do is work on 8.3. So we're going to do both of those on Thursday. So let's start with the first 5 on naming compounds. So notice that it's the first 5. I'm not going to try to give you the answers here. I want you guys to race each other, and let's see how many of you can get the first 5 done first. So I want you guys to go through and actually try to put in the names for all 5 first. So go. Oh, that's not your fault. Emily Mongold, you are not wrong, but I want you to name it not by the name that the poly would have, because that is actually nitrite, but don't call it nitrite. Actually name it, go through and use the rules that we just talked about, if that makes sense. So I'm sorry that it's actually starting with a poly, but go through and actually name it as nitrogen and 2 oxygen. So how would that be? And Emily Carr, you actually have one mistake on that first one. So I want you to fix that for me before I'll count it as being correct. And Emily M., don't forget your prefixes. Remember, on sodium bromide, you have to tell me how many of each element there is. So if it's the first one, you don't have to say mono, but on the second element, you do have to include that prefix mono. Alright, I will type my answers here so that you guys can see. That's the first one. Emily Carr, did you miss number 2, the NABR? I wanted you guys to try to actually erase each other, but to put an answer for each and every one of them down. Because I see that you answered number 3 as well. I like the way Jordan did this the best. He put them all in one text feed, so I don't have to scroll up and try to find what his answers were. So let me check. Jordan, you may have won. Let's see. Good. 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 Okay, so Jordan, I'm going to say that you got all of them right except for number 4. So Jordan, if you can fix number 4 before the ladies do, you'll have won the race. And Emily Carr, your number 4 isn't right for you either. So you do have the first part right, but you don't have the second part, the bromine. Because you put bromate, and that would be BRO 2 or 3 or something like that. Don't celebrate yet, Jordan. Go and fix it. Fix number 4. Okay, good on the ending. But Emily, don't forget that you also have a prefix to add. So what's the prefix for having 4 bromines? How do you show that you have 4 of them? Not quite, Jordan. It's not phosphorate. You were more correct to say phosphorus and bromide. You just need to add the prefixes now. That's all. Emily, again, you forgot the prefix on the bromide. Okay, it's not bromate. Bromate would have an oxygen and maybe 2 or 3 oxygens, but that's not correct. It's bromide. How many of the bromines do you have? Like, what's the prefix to show that you have 4 of them? Go back to the table, guys. It's on page 248. Excuse me. I'm sorry. Yay! The battle of number 4 is done. Diphosphorus tetrabromide. Although you didn't spell phosphorus correctly, but that's okay. Alright, so I am going to say, Jordan, you are my official winner of this race because you had answered all 5 of them correctly first. Emily, you still had to answer number 5, so I'm giving that one to Jordan. Alright, guys. In order, I will go through and name them, and you can check your work. Number 1 should be nitrogen dioxide. Number 2 should be sodium monobromide. Number 3 should be silicon dioxide. Number 4 should be diphosphorus tetrabromide. And number 5 should be iron sulfate. That's it. Alright, so let's go ahead and scroll down to writing formulas, those practice problems. And, alright, so, Emily, good job on those. The only thing is put a space between silicon dioxide, put a space between phosphorus and tetrabromide. And also, don't forget, number 5 should be, because they use the poly SO4 as an actual poly, I know I just got done telling you guys to not name your polys as polys. I'm sorry, that's really confusing, wasn't it? You would have to name SO4 as sulfate, and because it's with Oh. Shame on me. Shame on me. Bad teacher. Do you know what I forgot? I forgot that I gave you a mixed review worksheet. I forgot that we had ionic things in here. Do we use prefixes for ionic things? And the answer is no, we don't use prefixes for ionic things. That was my bad. I'm so sorry. Let's go through and fix this. Nitrogen and oxygen are both nonmetals, so this is covalent, so we would name it with the covalent rules. That is nitrogen dioxide. But number 2, sodium is a metal, bromine is a nonmetal. This is ionic. We don't use prefixes for ionic substances, so it's just sodium bromide. I'm so sorry, guys. Number 3, again, silicon. I think silicon is a metalloid. So we would name this covalently, so we would say silicon dioxide, so that's correct. Number 4 is ionic, or covalent, so it should be diphosphorus tetrabromide, so that's fine as well. But number 5 is actually ionic. And so because number 5 is ionic, you have to not use prefixes. It's not anything like that. You say iron sulfate, but you have to include something to show the charge on that iron. And so remember, sulfate is a -2 charge, so the iron must be a +2 charge. So you have to use your Roman numerals. So I'm going to type this one in here. Number 5 should be and I need to apologize again as a teacher for not catching my... I knew I gave you mixed review. You're right. I'm sorry. Emily, you did it right the first time, and I'm sorry for confusing you. Good job. So you get to have that one on your belt. You can say, I was right when Mrs. Sanders was wrong. And you can remind me of that later. Alright, so now we need to go down to the second part where we're writing formulas. And I want you guys to race on numbers 51 through 55. I think that Jordan already worked on those. So let me go ahead and see. You guys just work on your own, and I'm going to check his. I'm not going to say out loud if his is right or wrong right away. I'm going to just type my answers here. So you guys go ahead and keep working on that. Alright, let's see. I have my answers. Check your guys's. Alright, so Jordan, there's a little bit of a mistake, so see if you can figure out what that is. Alright, so Jordan, you've got a mistake in number 52, and you've got a mistake in number 54, and you got a mistake in number 55. So go through and fix those 3 for me. Emily, I'm kind of confused as when you said 51. Is that supposed to be H1, or is that supposed to be an HI? So I can't tell. So if it's supposed to be a And an I, please make sure you retype it so that it looks like And Emily, don't forget with number 51 and 52, they are both acids. And so you have to have hydrogen with both of them because an acid must start with hydrogen. Okay, so that makes more sense, but unfortunately that's not right because the hydrogen is with something. So it's not just one hydrogen. You have to actually put the other element that's with the hydrogen. Because notice it says hydroiodic acid. So what is that iodic standing for? Which element is that supposed to be representing? And Jordan, I hope you are trying to fix those 3 ones that I showed you. Don't just sit there twiddling your thumb. Try to go back and figure out what your mistakes were, Jordan, so that you can fix those. Good. Okay, so Jordan, here's, good. Emily, you got that one right. Jordan, number 52, you are correct that there's H2 and then an S, but you don't have a 4. It's just H2S because you take the charges of your hydrogen and your sulfur, which is a +1 and a -2, and you crisscross them to get 2 hydrogens, 1 sulfur. And then your only mistake in 54 was that you had the wrong symbol for nitrogen. Nitrogen is not Ni, that's nickel. And so Ni is nickel, nitrogen is just an N, so you should have just written that as N2O5. And then in 55, your mistake is that S sulfate it's a poly. So go and look at your polysulfate and see what you should have for that instead. Alright, so most of you are at the point where you can check your work. Here are the actual correct answers for these. So go through and let's look at them together. So number 51 is hydroiodic acid. And so when you hear hydro in the name, you should think binary acid. And so we know that we have hydrogen and we have iodine because iodic, the root there is io for iodate or iodine. So now we just have to figure out what our subscripts are. With your acids, especially your binary acids, you are going to have to figure out your subscripts, and it's just like when we did chapter 7 and we took the charges and we crisscrossed them. Hydrogen is always a +1, and then in this case, your iodine is a -1, and so they crisscross to be a 1-to-1 ratio, so you have HI, and that's it. So you just have to write HI like hi, and so that's the answer for 51. 52 is going to be hydrosulfuric acid. So again, we have that prefix hydro, which makes us think that this is binary. And so because it's binary, we know that we have hydrogen and one other element. And the sulfur that's referring to sulfur. So we're going to take hydrogen and sulfur. But hydrogen is a +1 charge, and sulfur is a -2 charge. So when we crisscross those charges, you have to have 2 hydrogen with 1 sulfur. So that's why it's H2S. Number 53 is calcium sulfide. And again, when you think calcium sulfide, that's a metal, so you know that this is ionic. Excuse me. So when we have calcium sulfide, what we're going to do is put calcium, and then we have to have sulfur with it, because we have it's not sulfate or sulfite, so it's not a poly, it's just sulfur. It's got that IDE ending, which indicates to you that it's just one element, just sulfur. So we know that we have Ca and S. And then you have to check your charges because it's ionic, and calcium is a +2, sulfur is a -2, so when you crisscross the charges, you end up with a 1-to-1 ratio. So it's just CaS, and that's it. Number 54 is dinitrogen pentaoxide, or because the double vowel, you drop the A, so you just say pentoxide. So we're going to end up with 2 nitrogens, because it's dinitrogen, and then 5 oxygens. So you got to write N2O5, dinitrogen pentaoxide. And then 55, aluminum sulfate. And this is, again, ionic, so we're just going to go straight forward. The aluminum is Al. Sulfate is SO4. Oh, that's what I forgot to do. I did crisscross my charges there. I apologize. So let me fix that. Number 55, aluminum has a +3 charge, and sulfate has a -2 charge. So you should have 2 aluminums, and then in parentheses, you have SO4, and you should have 3 of them. So this is how aluminum sulfate should be. It's Al2, and then in parentheses SO4, and you have 3 of them. And that's because the aluminum has a +3 charge, and the sulfate has a -2 charge, and so you crisscross those charges, and you end up with Al2SO4 3. Alright, so the only thing that I think with the, oh, you went on to do 56 ALS. I think you were meaning to write down 55. But the SO4 is sulfate. So you guys, look, the biggest thing I told you guys when we memorized our oxy anions and our, when we memorized our polyatomic ions, was that we're going to use them for the rest of the year. And so you just took your tests, and they were on Chapter 7 test. Your polys were all over the place. You are going to have them on Chapter 8 as well. You're going to have them on Chapter 9. You're going to have them for the rest of the year. So you can't forget what your polys are. So if you've already started forgetting those polyatomic ions, I would go back and re-memorize them and make sure that you are keeping them. Don't forget about them, essentially. So make sure that you are practicing those. Remember when you do the other 40 problems, remember 20. You want to make sure for the first section, naming compounds, you go to number 25. And then when you're doing the writing formulas, go to number 75 as well. So when you're doing those 40 other problems, keep your book open, look at your polys, make sure that you have those so you get, whether it's sulfate or sulfite or chlorate or chlorite or whatever, or hypochlorite, whatever the case may be, look at your polys, look at your prefixes. Don't forget to remind yourself whether you use hydro or whether you don't use hydro. Practice them correctly. It's not about being fast right now. It's not about not having any resources to help you. The best thing for you during this time is to practice correctly. And so I would highly encourage you guys to use your book and use your notes every time you practice when you're doing these problems. And that way you do it correctly every time. Now I'm going to give you your homework, and then we're going to be done because it's 3:06 and that's been an hour. So your homework for this this evening, or next evening until we get to Thursday, You're going to read pages 253 to 260. So read pages 253 to 260. And you're going to watch all of the videos that have to do with section 8.3. So if there's more than one video, make sure you watch all of them. And Emily Carr, don't forget thing 2. Go back through and rewatch the videos, or watch them for the first time because you didn't watch them beforehand. Watch your videos over 8.2 as well. So on Thursday, we're going to start with checking the worksheet, and then you are going to, jump right into drawing Lewis structures. And so we're going to, really hit that hard on Thursday. And again, that's just something where you're going to have to do it, practice and practice and practice, drawing those Lewis structures, so that you get good at it. Other than that, I think that's it for today. Please, I'm going to stay on live for a couple more minutes. If you have questions, I'm going to let you type those in, and otherwise, at about 3:10 or 3:12, I'll sign off and we will be done. I'm going to give the extra time just as a buffer in case we have the lag time. And you're welcome. It was my pleasure. I'm glad we were able to have these video lessons, especially during the snow days, so that we were able to not fall behind in this class. Alright guys, I am signing out. I don't think you guys have any more questions, so please feel free to send me a message if you need help with the practice, or if you have any questions for me. Otherwise, have a good evening. Enjoy the snow while it lasts.